All right, so today we are diving deep into AI image generation. But not just any images. We're talking high resolution, jaw-dropping visuals. And get this, generated crazy fast. I know what you're thinking. Doesn't that need like a supercomputer or something? Well, that's where things get really interesting. Today we're talking about a system called Sana that is totally changing the game. And joining me for this deep dive is...
Well, hey, it's great to be here. And yes, Sana is remarkable. What's so cool about it is that it's not just bigger and more powerful, like a lot of these models are trying to be. It's smarter. The team behind Sana really looked at the whole process, how it understands what you want it to make, and then how it actually makes the image. And they found a way to make both of those things way more efficient.
And when we say more efficient, we mean light years ahead of the pack. I mean, check this out. We're looking at figure 2 here from the research. Sana can create a 4K resolution image, that's the super sharp stuff, in just under 10 seconds. 10 seconds. The leading model right now, which is FLUX, takes over 16 minutes for the same thing.
Yeah, you're talking about a difference. It's just staggering. Anyone who's ever, felt limited by these long rendering times or they need some crazy expensive hardware just to make an image, this is a game changer.
Totally, totally. And it's not just about the crazy high resolutions either. Figure 4 shows us that even at 1K resolution, which, let's be honest, is still really good, Sana is 40 times faster than the competition. 40 times. And it does all of this with a surprisingly small model size.
That's wild.
It really is. It's like this little sports car that can outperform a giant truck.
I like that analogy, and it really highlights why efficient design is so important in this field. Just imagine, running these AI models on your laptop, no need for a server farm. You could have real-time creation. Artists and designers could make changes super fast and see the result immediately.
The possibilities really are kind of endless when you think about it like that. Okay, so we've established that Sana is fast, like ridiculously fast. But how did they manage to pull this off? Because when we look at the research paper, they're throwing around terms like deep compression autoencoder and linear DDIT. And frankly, I'm like, I need a translator over here. Luckily I have one right here. So what say you? Can you break those terms down for us?
Yeah, I get it. Those are definitely some terms that can make your head spin a little, but they're actually pretty cool concepts once you break them down a bit. So let's start with that deep compression autoencoder.
Okay, yeah. Let's unpack that. Deep compression autoencoder.
It sounds intimidating, not going to lie.
It really does, doesn't it? But it's simpler than it sounds, honestly. Think of it like packing for a trip. You wouldn't just throw everything in your suitcase randomly, right?
Definitely not.
No way.
I'd never be able to fit everything.
Exactly. You're going to fold your clothes neatly, maybe even use some of those space-saving compression bags.
Yeah. Got to get that extra pair of shoes in there somehow. Exactly. So those compression bags, they help you fit more stuff into a smaller space, right?
Yeah.
And that's kind of what Sana's autoencoder is doing, but with image data.
Interesting.
Yeah. So most AI image models, they compress images, but only by around 8 times to make things faster. Sana kicks it up a notch. It compresses the image data by a whopping 32 times.
32 times. That just seems wild. But doesn't squeezing all that data down mean that you're losing detail? Like, are we sacrificing quality for speed?
That is the million-dollar question, right?
Yeah.
And that's the really ingenious part.
Yeah.
They managed to pull off this insane compression,
Yeah.
but without sacrificing the image quality at all. And we can actually see that in figure 3.
Yeah.
So by working with fewer but much more densely packed data chunks, the model can process all that information way faster.
So it's like instead of sending this giant unwieldy file, it's sending a super compressed version. But it still looks exactly the same on the other end.
You get it. That's essentially what this autoencoder is doing. Yeah, it's pretty elegant when you think about it. And it's a game changer for speed, especially when you're talking about these super high resolutions.
Yeah, that makes sense. Okay. So we've got this super efficient data compression thing going on. But what about the AI smarts behind it all? That's where this linear DDIT comes in, right?
Bingo.
Okay.
So DDIT stands for Diffusion Transformer. And that's essentially the brains of the AI model.
Okay.
Traditional DDITs, they use something called attention mechanisms. And what this means is they're looking at how different parts of an image relate to each other, like how the shape of an eye connects to the shape of a face. you know?
So it's like the AI is paying attention to all the little details to make sure they make sense together.
Exactly.
Okay.
But the thing is, these attention mechanisms, they can be a little slow,
Mm-hmm.
especially when you have a really high-resolution image with tons of tiny details.
Right, because there's so much more to pay attention to.
It's like trying to have a really deep conversation with a million people at once.
Oh, wow.
It takes time.
Yeah, and time is money, as they say, especially when you're waiting for an image to generate, right?
For sure. So to speed things up, Sana uses a linear version of these attention mechanisms. It's like they've streamlined the process, making it much, much faster, but without losing that attention to detail.
Clever. So they've found a way for the AI to still pay attention to the important details without it, like, getting bogged down.
You got it.
Very cool.
But that's not all.
Oh, there's more.
Oh, yeah. There's more to this speed boost.
Yeah.
They've also integrated a decoder-only small LLM.
Hold on, more acronyms. Okay, what in the world is an LLM, and what does that have to do with images?
Uh-huh. Yeah, sorry about that. We do love our acronyms in AI, don't we?
Oh, you do.
So LLM stands for Large Language Model.
Okay.
You can kind of think of it like the AI equivalent of a master chef.
Okay.
You know how a master chef can just look at a recipe and understand it perfectly?
Yeah.
Even if you're using really creative language in the recipe or you left out a few steps?
Right, they just know.
Exactly. They just know. That's kind of what an LLM is doing.
So how does a master chef help with image generation?
It's all about understanding your text prompts. Sana is using these LLMs, which, remember, are amazing at understanding and generating text. They're using them to better grasp what you're asking for in your prompts.
Oh,
So it's like having this super smart interpreter.
I see.
They can translate your creative vision into something that the AI can understand and work with.
That's really cool.
Yeah. And to make things even more efficient, they chose to use these decoder-only LLMs, which are even better for this task.
Wow, so smart.
It's pretty wild, right?
It is. So we've got the data compression, streamlined AI brain power, and now we've got this like master chef LLM who's taking our orders and making sure the AI gets it just right. Is there anything else contributing to Sana's speed?
You know what? You're not going to believe this. But there is.
Yeah.
There are actually a few more tricks up their sleeve.
Yeah, there are. And this part is really about how they're training and running the model. So it's a little less about the model's design itself and more about how they're actually using it.
Okay, so like optimizing the process.
Exactly. Think of it like, fine-tuning a race car. You've got this amazing engine, but you can always tweak the aerodynamics or the tires to squeeze out even more speed.
I like it. So how are they fine-tuning Sana to run even faster?
Well, they're using a bunch of clever tricks. Like one thing they're doing is training the different parts of the model separately at first. So the LLM, remember our master chef, they can learn their part without waiting for the image generation part to catch up.
Smart. It's like giving each part of the team its own training montage so they can become experts in their own right.
Right. And then they bring it all together for the final training. And because each part is already really good at what it does, the whole training process is much faster and more efficient. So faster training, less time waiting around for results.
Exactly. But it gets even better. Remember how I said Sana uses fewer steps to generate images?
Yeah, that was one of the things that really blew me away.
Well, they've actually found a way to further optimize that process
Oh.
by using something called dynamic scaling.
Okay, now you're just messing with me. Dynamic scaling, what is that?
I know. More jargon. But it's actually pretty cool. Basically, it means that the model can adjust the number of steps it takes to generate an image based on how complex the image is.
Oh, that's interesting. So it's not just blindly using the same number of steps every single time. It's like, if it's a simple image, it can be like, all right, I got this, I can do it in 5 steps. But if it's super complex, it can take a bit more time and use more steps to get it just right.
Exactly. It's like a really smart chef who knows when to take their time with a dish and when they can whip something up quickly.
It's all about that efficiency. Less time, less energy, same amazing results.
Precisely.
This is all incredibly impressive, but let's talk about what you really want to know. What does this actually mean for you? It's one thing to hear about Sana generating a photorealistic image of a cat riding a unicycle on the moon in under 10 seconds. But how does that translate into something that you can actually use?
Yeah, that's the exciting part, isn't it? It's like,
Yeah.
okay, cool. Fast image generation, but what can I actually do with that?
Well, just imagine having access to this insanely powerful AI image generation on your own computer.
So you're saying I don't need a supercomputer anymore?
Nope, not at all. It's like putting this creative power in the hands of everyday people, not just big companies with tons of money.
I mean, think about what that could mean for artists, designers, educators, anyone who uses visuals.
Absolutely. A student could create these amazing visuals for a school project. An independent filmmaker could make their movie look like a Hollywood blockbuster.
And nobody has to break the bank to do it.
Exactly.
It's kind of like when desktop publishing first came out. Suddenly anyone could make professional-looking documents. Yeah. It feels like that moment for visual content.
It really does. But there's also the potential for using this in real time.
Oh yeah, for sure.
If Sana can generate these super high-resolution images so fast, what does that mean for video games, interactive art? What about personalized ads that actually look amazing?
Right, that's the future right there.
No more cringy ads.
No more cringy ads.
I can get behind that. But really, the speed and efficiency, it opens up so many doors.
Totally. It's not just making what we already have faster. It's giving people the tools to invent totally new things.
Higher resolutions.
More realistic images.
Maybe even video.
Oh yeah. Video is definitely on the horizon.
This is definitely one of those times where you just feel like we're on the edge of something massive. It's like when we all got our first smartphones. Everything changed after that. I think this could be that kind of shift for visual content creation.
It's definitely a really exciting time to be following this field.
It really is. So to wrap things up, Sana isn't just another cool AI model. It has the potential to change how we create and experience visuals.
And it shows us just how quickly things are advancing.
Who knows what amazing things we'll be talking about next year. That's what's so great about these deep dives. They make you think about the possibilities. And with Sana, those possibilities seem endless. Thanks for joining us for this deep dive into the world of AI image generation. And until next time, keep those creative sparks flying.